Thank you very much for being here. My name is Vladimir Vishnevskii. I would like to offer this talk that is called Efficient and Reliable Wrapping of C APIs using modern C++. So in C++ code, we quite often need to interact with C code. Yeah? So while we have OS APIs, we have hardware SDKs, we have various mathematical libraries. Yeah? So and introduction of some adaptation layer, yeah, that can adopt C APIs for more convenient usage in the first instance, and more safe usage in C++ language can be actually necessary and beneficial. Yeah, so we can achieve increased code safety. Yeah, so we can use safe resource management, we can have some type safety, we can have compile time error checks, we can enforce cons correctness, and also we can adjust the code a bit of the compile time. Yeah, we can do some pre-computation. We can also adjust the interfaces depending on some compile time information. The compatibility with some C++ language and constructs. Yeah, so there are more synthetic constructs or just some standard facilities that are available in C++. Plus maybe goes to the previous point, but generally utilization of C++ error reporting that is a bit more has a bit more of the parents and mechanism than C can also be beneficial. Yeah, so generally speaking, so today I wanted to review some architectural patterns that can be utilized, yes, so to adopt the C APIs for C++ language, yeah, to provide this safe and convenient usage, as we mentioned before, and also review some language features and standard facilities that are available up to C++ 23 standard. Yes, so. And I wanted to do this using case. Yeah, so the case will be LMDB. This is a Lightning Memory Map database manager, very high efficient key value store that is implemented in C and has C API. Yeah, so it can, as a library can be embedded into program, has bindings for other languages as well, and there is a mirror for this project. It's part of the bigger project, but there is a mirror that has just LMDB mirrored there on GitHub, and there is it's a very good facility. We will be just looking at some subset for basically educational purposes. So this is not a talk about wrapping LMDB, but more about in general about the techniques and issues that we can see while doing this. Yes, so we will not go through the reference for LMDB. We will be just look at some usage examples to see what it is, how does it look like from the client point of view when we need to use the LMDB API. So first of all, there is a concept that's called environment. So there's an object that should be created. Several databases that can be associated with the environment. Environment corresponds also to some file system location where the data and metadata for some tables is located for the LMDB data. So environment is created using MDB environment create function, and it's returned as a pointer to pointer. So we pass the pointer as an output parameter. The function will return, this is the C++ code that uses C, so please don't be confused. Yeah, so that uses C API. We have, it returns the integer as a result code. So after environment is created, this is supposed to be open. We need to provide the path to the location, and then we also need to provide some flags. Some flags, for example, there is this MDB read-only flag that is specifying that environment is open in read-only mode. That means that all operations on the object associated with the environment should be read-only. No modification is allowed. This will be clarified. So this will be verified and checked on the runtime. So the fourth parameter is the default file permissions for the files that will be created within the environment. And I mean, generally, those both parameters have compatible types, and I can just easily misplace them here. And yeah, so by the way, it's by no means any kind of criticism of the C API, because this is just the reality of the C language. So it's not about anyhow of the design of specific API. So generally, if it does not work, we need to close the environment because we need to release those resources that were allocated for us. Yeah, so we need to, on every return branch, we need to do this. And then we need to create a transaction. Transaction is something that is needed when we want to operate, read, or access the data in general, and also create the table, for example. So here we create a transaction. Again, it is also returned as the output parameter. And here is, we are creating the table. So the database, yes, so the database in the table, so the database is a key value table, generally speaking, but it's terminology that it's database. So we provide the name, we provide the flags. The flags can be MDB create, MDB dupsort. So here we are asking to create database if it's not existent. This is allowed only if the environment is not read-only. Dupsort means that there can be a duplication of keys, so that several items can have the same key value. Otherwise, there should be unique keys. If something, and by the way, here again, I wanted to specify that I want the keys to be sorted in reverse order, but somehow typed that it is reserved. It's not this, actually flag doesn't belong to this function at all, but I somehow just put it here and probably get some error in the runtime. The thing is that, again, those is just constants that I can specify. If something is not working, we need now to release also transaction and environment. Here without, MDB put function to put the data. It accepts the values that we need to put for key and value, plus also some flags also that control the insertion mode. And the data is abstracted, so items, the value and the keys, they are abstracted as this structure MDB val. Kind of C-span, so void pointer and size. Non-constant pointer, just the size. MDB put function receives also non-constant pointers to these items. So just, and MDB get, it just gets the item by the key to find. We provide. Here I just use the helpers that produce somehow those MDB vals. So here we have key to find, then it also receives this key to find as a non-constant pointer to this MDB val that has the pointer to non-constant void. Okay. Continuous access to the database can be achieved using the cursor. So we need to open cursor. We then can iterate the cursor. So there are operations, MDB first, MDB next, there are more. We can do various operations. The idea, it can be used in the for loop. This navigation operation, like MDB first, MDB next, it also reads the data located on the position where it will be placed. So here we are moving cursor, plus we also acquiring the data from the database. Okay. And we need, of course, then to kind of deserialize the data that is stored, because we provide it in the form of the basically void pointer. If we want to put it back, we provide this current key and current value that are MDB vals. We can, of course, do something wrong here, like, for example, just misplace them. And this is all, the client is, of course, responsible for this, because this is something that is not covered by the essential LMDB facility. So, generally speaking, we saw the API, yes. So, generally speaking, what we can do, So there are some issues that are mostly caused by the specifics of C language, yes. And the question is that what can be mitigated, by using C++ maybe to just somehow like adopt this API. And the question is, that's quite important, that we need to understand what we want to achieve. So one thing is that we want to have the full C++ binding of the whole functionality of LMDB. This is one case, So then this and also requires some effort, Or it is just some form of the limited use case. So we just need to use the API from some C++ code. We will be looking at the binding solution because it's more challenging, but on the other side, there will be techniques that, of course, will be applicable for another cases as well. And another question is, what is isolation of dependencies we want to achieve? Because the one thing is that we can use some kind of a header-only layer where we need to include the LMDB, and it stays there and still the kind of headers are exposed to the client code, or we actually need to sieve it in CPP, because this is where we are limited. We will look at some different cases here, but I will mostly kind of forward on the, will mostly focus on some header-only solutions, but yes, I will point out at some specifics there. Yeah, so, okay, now let's look at some C++ hypothetical usage example. Yeah, so what we could achieve, it's elaboration. Yeah, so it's not something that I would say just perfect. We are going through that and just discussing these some ideas and solutions. So first of all, of course, it would be beneficial if there will be a possibility to, generally speaking, create the objects and hide all this multi-step initialization and creation, acquisition of the different resources. So when we can create the objects, and we can have some different factory functions, and one object, so some objects can create another dependent objects, for example. Yeah, so it also would be good if our repo, yeah, will allow to work with concrete types, yeah, so that we do not need then to work with this MDB val, that we do not need to be responsible for this particular specifics in the client code here. Yeah, so generally we also, as we have the concept of this read-only environment, why not to actually eliminate the whole class of the problem and just say that if we open in the read-only environment, we do not have read-write operations there at all. Yeah, so here we provide the compile time flag that will make our environment read-only. That means in those whole environment, we will not be able to perform any kind of operations, and they will be just not available because there will be no functions that could do this. So on compile time, we could do that. Plus, we also have some standard C++ facilities, like, for example, we can do the range-based for loop. Would be nice if we can just iterate through items in those loops. Also nice if we can call the, use the standard algorithms on our items that are stored, and maybe even use them in the ranges, for example. Yeah, so in the range-based algorithms. So as we are going into compile time, it's also important that we still provide types that are used in concrete instantiation. Yeah, so because we configure in compile time our objects, it's important that we still can get the types, because the client would like to maybe use those types in some other functions. Yeah, so here we know that in our read-only environment, we will have read-only view following this nested kind of declarations, and then we can use it here. Because we do not want to force the client code to use some template metaprogramming, so we can do this. Okay, so let's now go through these usage examples and dissect this, see what we were using there to achieve this, and what can be done, and what techniques we can use. Okay, first of all, yeah, we saw that there is this creation of an environment object. So the first thing what we need to kind of agree on, what kind of error reporting mechanism we are using here. Yeah, so here the either environment object is returned or the error code. So error reporting is quite important. Yeah, so C, it just reports errors either with the return types or with the return values, or it can use output parameters. Yeah, C++ standard, it has some, now, especially in C++3, it has several facilities to handle return values. Yeah, so C++ also has exception mechanism. So generally, anyway, regardless of what technique we will be using, yeah, we need to somehow use the LMDB return codes and adapt them to be used from our C++ repo. Yeah, so the simplest way we can go is to use the scoped enumerations with the fixed underlying type that corresponds to the type of the return type of our LMDB API functions. So then we can use the values that are specified in the LMDB headers. This is if we can use the LMDB headers within our repo. So if we can expose this to the client code, yes. And the idea is that starting from C++17, we can just simply initialize the enumerations with the underlying type, if the underlying type is fixed. So we can use those to just, and the client code will use this error T type and will be scoped enumeration. So it will be easier to actually handle those types than in the client code. So if it is not possible, yeah, so then we need to actually translate the values, yeah. So otherwise, I mean, we can try to use some different techniques, but generally speaking, as we are not assigning those values, we need to take responsibility for actually providing the correct values. So we cannot then use those values from the header. We just use some arbitrary values and then translate those. So something like this. Starting from C++23, we have the facility that is called std expected. Yeah, so this one is actually an abstraction for return type and or error type. Yeah, so we have some expected type, so this is the one that is returned in the positive case. We also have another type that is the one that is returned in the negative case. The expected, so it has the interface that is similar to optional. Offer, it's more like a variant, yes, but it is like an optional that either has the expected type or has an error. So it also has the dereference operator, it has error operator, with the same semantics. So it throws on the attempt to get the value by value method, but it doesn't throw if we try to dereference it. And the error type is available if we call the error method. Yeah, so the idea here, yes, so this is what we are doing. There are alternatives and backports, yes, so this is possible to use pre-C++23. There is a boost outcome, there is a non-std expected, so this is possible and available in the open source software as well. And that can be used, yeah. So generally, it is also possible, of course, to use exceptions. Yeah, so this is the question that we need to make as a design decision. But first of all, if we look at the exceptions, yeah, we can have a distinct exception type for, of course, for our LMDB issues. In our case, it will hold this error code, yeah, and will provide this error code, and we can also have the what implementation that will provide some kind of readable explanation of the errors. Yeah, exceptions. Generally speaking, it's quite easier it makes client code much easier. Yeah, so we can write the code for positive case, expecting that everything is okay. If something happens that is unexpected, then we handle the problem. In this example, this is easier. There can be some other examples. So actually, writing, of course, exception-safe code skills are required. But yes, for those specific cases, it's really much easier. We see that. And plus, there is also another very huge advantage, is that exceptions, they can be thrown from the functions that either do not return, like, for example, constructors, or the functions that have predefined return types, like, for example, operators, yeah, so when we want to have it. And they can be thrown from those, from constructors, or from just standalone functions, so they can be used in different cases. But some projects, they do not use exceptions, or they cannot use exceptions. Exceptions, sometimes they're syncretical. There are some industrial standards that are actually not allowing this. The problem is that if we are using exceptions as the primary tool of reporting the errors, then we are forcing the client code to use it. And this can be a reason why no one will be using our facility, generally speaking. So the more simple, so the more kind of way that, the more safe way in this case would be probably to use return types. But also there can be some ways maybe to do some configurable error reporting, because if we have, so there is some connection between, of course, expected and exceptions. Yes, so we have, in case if we throw in the throwing function, we have our expected type to be just a return type, yes, and expected, yes, here returns this expected, also has this expected type, yeah, and in case of error, we sorry, it would be better. So in case of error, we throw the error or we return the type that is error type. So we can try to use some preprocessor facilities to actually handle this and have it configurable. So either we return or we throw. With some limitations possible to achieve, plus we also can have configurable the way what abstraction are we using for this return type, like, for example, the expected or maybe some other third-party solution. Yeah, so, but yeah, this can be considered. I will be using just no except versions in the further examples, but yeah, so those will be kind of controlled by preprocessor. So here are the environment flags. Yes, so here we are providing none of them. Again, this is the flags. The second one is the number. So there is this one that is standing after the comma. Yeah, so this is the number of databases that can be opened within the environment. Generally speaking, the flags and those they are so there's also unsigned integers. Generally speaking, they can have compatible types. We also do not want to have those types to be misplaced, these parameters to be misplaced. We also need to use the safer, more strong type. Yeah. So here our scoped enumeration helps as well. We do the same things that we did with the arrow. And now in C++23 we have std to underline that helps to get the value that we assign to that. This, by the way, absolutely trivial implementation. Of course, probably everyone has it in their own kind of utility frameworks, but generally now it's a part of the standard. Yes, so something like this. And to use those flags, yes, we also need to provide the we need to provide specialization. So we need to provide the implementation for the bitwise logical operators, yeah, so because they are not available for scoped enumerations. Okay, so now we see that we using factories, yeah, to create the objects. We have some hierarchy, logical hierarchy within the LMDB database. So we have the environment, and some databases belong to environment, and then the data. Then we start transactions to modify the data within the database. So the parent objects, they somehow produce children objects. Yeah, so this is what is happening, and this gives an advantage because this can better preserve encapsulation. The upper layer objects in this hierarchy, they have their internals are sufficient to actually produce the child objects. Yeah, so here, for example, we have environment. We can create the database object, and then we can just return it from the factory function. If we will be building more the solution that where we provide kind of a parent object into the constructor of another object, then we need to somehow expose the internals. Yeah, so here either we need to actually just break encapsulation, provide the access to this internal, or we need to set up some friends. Yeah, so the friendship in this case is better because it still limits the access. Yeah, so it's we are specifying what is it. But because here we are just completely making access possible from the code that doesn't belong to our wrapper. Yeah, so this is something that is should be considered. Okay, so plus yes, factories we are more flexible with the way how we are reporting errors. And we also can propagate some compile time options because the parent object has some compile time configuration, and it can also and it knows what type it will be returning. Yes, so it can use those for the return type. Okay, so what we see here also is that if we have some error, we can handle the error somehow. And then we can just return. Yeah, so we do not have any explicit disposal of any of the resources. Yeah, so here. This is because we are using RAII idiom or RAII pattern to handle the resources. Yes. So generally speaking, minimalist RAII handler. So RAII, this is resource acquisition is initialization. The idea is that if we acquire some resource, we initialize some handler, and lifetime of this handler manages lifetime of resource. Yeah, so generally the simplest handler that can be implemented in that way using the standard facilities is a unique pointer with the custom deleter. In our case, so what we do for the environment, we call MDB environment close. Yes, so this is something that we can do. And yeah, so the API call is placed in the deleter. And we can use the alias just to not to repeat this all the time. There is a possibility to specify that we want to use just a function as a deleter, it brings some limitations. Yes, so first of all, it will not be default constructible than our handler. And also, generally speaking, we are here introducing the function pointer, and function pointer is in direct call, so it will be very likely optimized, but depends a bit on some conditions. So generally, it is explicit in direction, and the compiler depends on the way how it will be optimized away. So it can stay there, yes. So it depends on what use case and what are the requirements. It can actually add some extra runtime overhead. Yeah. So just the one should be a bit careful with this. How does it work? So generally what we are doing, we are just take the LMDB pointer, we provide it into the function, and then we just create our handler providing there the pointer. C++23 now has some helpers to help with this. So there is this function, stdout pointer, that provides the helper function, or that returns the helper type, that is compatible with the pointer to pointer, and generally it will be used within the function. And this is first of all convenient. On the other side, it's actually better because we do not have this intermediate state where we already acquired the resource, but it's not yet handled by the pointer. Yes, so generally, so it returns std output pointer underscore t. This is the type that can be converted to the type that can be used by the function. So yeah, if we are talking about something like transactions or some resources that we need to somehow manually either commit or dispose or have some handling, and it is managed by RAII wrapper, so then our API can look like this. Yes, so we have our handler. Here is just example for LMDB, but generally what we need is that, we can somehow like acquire the resource, getting this handler, and then the functions that dispose the resource, they receive the handler by right value reference. Yeah, so that will require that we move the handler into the function. That will be semantically clear because the function will consume it then. Plus, we will also enable some static analysis checks because it will be seen that the object was moved and should not be used. Yes, so plus, and also more readable in that way. Okay, so our environment. And by the way, this handler, it is convenient regardless if we are trying to provide the bindings. It's one of the useful facility if we're just using the C code in C++. So this can be done. Yes. So environment base. This is the base functionality of the environment type that we create by our function. It will just own this resource. Yes. So our environment here. So we are wrapping further. And it will also, yes. So, okay. So now, as we mentioned, we can specify that environment is supposed to be read-only. Yes, so that's what we would like to achieve, just to eliminate all incorrect access to read-only objects. Yes, and we also mentioned that we want to have these types to be available. Yeah, because of this use case. So generally, one of the approaches that can be used, we just split the types. So we have a read-only environment that inherits the environment base, providing this alias that we need, and also provides the functionality to open read-only database. And then we use the same pattern with other objects, yes? And the same, so only read-only can be opened here, and read-write environment will extend read-only, adding also alias for read-write plus opening the read-write database. This is one of the approaches that can be used. Then, here we just introduce a helper that will identify if there is a read-only flag set within the environment flags, as there are multiple of them. And I'm also using the more strong alias for bool, just to increase safety and readability, because it I think a bit better than just using the plain bool values and types. And we can then conditionally return something. Yeah, so our make environment conditionally returns either read-only environment or read-write environment based on the compile time parameter. Yeah, so we specify read-only. Here is a helper facility environment underscore t that has this read-only t as a parameter, and then it returns the type and handles this based on this template parameter. So yeah, but alternatively now, starting from C++20, we can also, in much kind of simpler way than before that, we can also disable some interface based on what we have, based on compile time configuration that we have. So here, for example, we have read-only, and we use requires to require for this function, that this function requires that this condition is satisfied. So generally, this is a simplification of all the enable if patterns and facility was used before, but enable if is of course also available still, but now it can be used in much simpler way, just done with much simpler way using this requires. Okay. So, but yeah, in this case, there will be no aliases. So that's why just this is an alternative that is not exact substitution of what we did before. Okay. One more important thing. Yeah. So the C++ code, our repo code, can actually, from the constant qualified methods, can perform, can call the mutating API functions. So for example, here we are just calling LMDB drop that deletes the database. Despite the fact that drop is constant. Why? Because we copy the values of the parameters. MDB, so DB index is just actually integer, the transaction we just created here. It's also the pointer. Yeah, so this is not good because we can substitute we can make this mutable and immutable types, but generally speaking, so even if the type provides the mutating operation, if it is constant qualified, it should not somehow perform the mutating operations. Generally speaking, it is recommended that C++ classes in general, yeah, so that the constant correctness is reflecting the immutability of the modeled object. Yeah, so in our case, the constant objects should not modify the database that they represent, yes, or environment or other entities. So we need to make sure that we enforce this logical mutability. That means that everything that can mutate should not be const. Everything that is read-only and supposed to kind of provide read-only access can be const. Yes, so something like this. Then our read-write environment, if it's const qualified, will not be able to open read-write database. So this is what we should achieve, but this is already kind of a responsibility of those who are designing the RAII. Yes, so this should be considered. Yeah, so OpenDB it will not be available. Yeah, so it will not compile. So it will be available, but will not compile because our environment is constant qualified. Okay, one more consideration. So we see that we have some objects within our adapters that are somehow has dependent lifetimes. Yeah, so we have environment. The environment is needed for everyone for databases. So it can be that this lifetime management, if we use it, if we have the shared object, if we control it using some facilities like shared pointer or implement some reference count, this can really improve some safety, but it also will affect the runtime. From my point of view, so the minimalist implementation is just essential. It's something that should be provided, yeah, and either it will be provided for a client to implement something like this if it is needed, because we cannot foresee all the use cases. But it's important that we have something minimalist from which the more complex structures can be built. So that means that the more complex solution, they can be beneficial, yes, but not essential. So the minimalist thing is something that framework should provide. Okay, so now one more thing to mention. Yes, so we have our database so it stores those serialized objects, yes, so regardless of the way how it's abstract. So it has the bytes. We would like our client code not to work with those abstractions, but actually to work with the concrete types that we want to store in the database. So this can be done if we adjust our database object using some compile time information that we can provide in form of the template argument. Yes, so generally we can design this, and there are what is also important is that we generally should, of course, in any case, should prevent the client code of the repo to operate with the LMDB types directly. Yeah? So first of all, this MDB span should not be, MDB val, sorry, should not be visible for the client, regardless of what kind of interaction is happening. We will be using another abstraction, C++ abstraction, for those kind of continuous data that that we need to kind of prepare for the database. So we'll be using std span. Yeah, so this is C++20 facility that is finally there. Actually, it's very convenient, and I recommend it to use to be used. Yeah, so there are also backports available. So we also need to enforce that for client code, the access, the view into the data that is somehow stored in the database is constant. Yeah, so that we do not modify anything that is stored in the database. Also, for us, so we would use this alias that byte span that is actually span of the immutable bytes, and we introduce the helpers to convert between our byte span and MDB val. We also will handle the issue that this pointer is not constant. So the functions, they guarantee not to modify, the LMDB functions, they do not modify the data when we provide, for example, key to find the value, but we always provide them as non-constant. We do not want that to be visible for the client, so yes, we handle this here and hide it. Yeah. So so generally what we need to provide the rules that how our C++ types will be converted into the types that LMDB can store, actually the byte, some byte vector. This can be done using the traits pattern. Yeah, so we are providing the traits to do this. So this is similar, so this is in general, yeah, so if we would like to somehow build the bridge, yeah, between our typing and the typing that is used by the framework, not specifically for LMDB. So here it is a template parameter, and our and here is just an example. We have traits. The key trait is the trait for the key object, the value for the value object. We have unsigned integer and string types. So we store the key as integer, the value is string. So we will elaborate this with more details, and we also can provide some parameters of LMDB database. For example, this duplicate key flag. If we specify that it is kind of a true type, then we specify that the duplicates of the keys are available inside. Yeah, so those are parameters. Why it is so, we will look a bit late. So we will come to this. So this is an example of UN32 traits. So we need to provide the 2 bytes and from bytes functions that will be used internally by the repo. So this is the client code. So the clients who would like to use this, they need to provide this facilities for the repo to know how to convert their types into the bytes, basically, and other way around. So 2 bytes and from bytes. It returns the byte span. 2 bytes return the byte span in our case, and the from bytes it returns the value type. So here, by the way, also another C++20 useful thing, as bytes takes the span and converts it to the span of bytes. So generally speaking, if we have more complex serialization, when we need to, we can we need to return some storage of the data. Like for example, here the vector of byte, because we use compress here, it doesn't correspond to actually the bytes of the object. Yeah, so it just some other data that was produced by compress operation. So it will be good if we can actually, we will not be that restrict what we are returning. Yeah, so and this we can achieve generally speaking if we really kind of treat those types as, because they are compatible with spans, the vector and span itself. Yeah, so what we can do within the function, so we're using the traits to produce the kind of bytes views, that's our byte spans, and then we use our helpers that we specified before to provide this MDB vals, and then we just put them into the function. Yes, so that's how it is supposed to be. So that means the objects that are after this function was called, the objects that were there were parameters, their representation is copied into the function. And this we can restrict, yeah, so our deserialization and serialization traits we can restrict, so we can then use concepts to specify how those functions are supposed to look like. This documents the code better, we get the better error codes, we can use those traits to verify our code without instantiation of our database. Yeah, so the idea here we specify, yeah, so that our deserialization traits should have from bytes, and the from bytes method that returns the value type, and our serialization traits should have 2 bytes. Those are the static methods. Yeah, so also they should have value type, and it should return something that is convertible to the byte span. So something that we can construct byte span from. Yeah, so and plus our traits, they can also provide the custom comparison function that can be used to store the key and values within the LMDB database. So this is another thing that those traits can provide. Here, this CMP function, it can provide some custom logic. It also operates with byte span, so with the client visible types that are constant, not with MDB vals. We can detect the presence of this in the trait, again using this request facility. Yeah, so we are so the expression will evaluate to true if this is well-formed operation for some type name T. Yes, so in our case it will be our trait, and we need to adapt our function that is provided by the client to be actually set up for the LMDB. So here, first of all, we can check if this trait is present in the compile time, and then call set compare. This is the API call to set this function, only if it is true. And then what we do, so we use some adapter that is generic. So it has the trait type, and then it just forwards the call to this trait CMP, converting the MDB vals that here, by the way, are provided by constant pointers into the span representation, the byte span. So here we instantiate it with the key value trait, with the key trait, and it then just forwards this to the static function that was provided by the client. So just kind of adaptation of the one function to another. Yeah. So, but they are of course both static. So the we need, so for keys and for value traits, yeah, we can then build more complex concepts. They both need to provide the serialization and deserialization specification, plus they can also be used to verify consistency of some other parameters that are LMDB specific. We will not go in details, but we can use those in the compile time to check the consistency of the parameters. And the key value trait that the client provides, this is the one, the template parameter of our function, create database. It will needs to have the key trait and value trait, and it also requires, just an example, so that the sorting of the values is relevant only if duplications are allowed. So it kind of checks the consistency of the overall parameters with the trait parameter. So this can also be done, and then in the compile time to prevent client to provide the parameters that are not consistent with each other. Yeah, so we can have already these things verified. Yeah, so something like this. I mean, this is an example for compile time checks and actually error avoidance. Okay, so now a bit about the inspection of the values. and traversal of the database. Yeah, so we here have the our iterate by key function that belongs to transaction. Yeah, so we call and then we use the range-based for loop. Generally, and also we have some algorithms that are compatible. So we have the ranges algorithms that we run on the values that are in the database. So to implement this, we generally speaking need to implement iteration. Yeah, so we have the cursor. We have a cursor concept within LMDB. The cursor works to provide the continuous access to the items. Yes, so to provide compatibility, yes, with those standard facilities, we need to adapt the cursor to work as iterator. And the standard, it has kind of specifies several iterator categories and basically types, yeah, and we need, based on the kind of abilities of the lower level API, we need to pick the one that kind of works in our case. So generally speaking, this acquisition of the data from the databases looks like an input operation. Yeah, so we are doing this continuously unless we achieve some condition where we cannot do this anymore. Yeah, so some kind of error happens or something like this. And this corresponds to the input iterator category. So, and now what is good, starting from C++20, those specifics of the different iterators, it's not only just the named requirements, but it's also documented in form of the concepts. It's still maybe not fully present in terms of the kind of standard concepts, but some of them are implementation dependent. So like those that are that are marked as the comments here. But generally those concepts are, they can be used and they also document quite well what should be implemented. So here, for example, for input operator, there are some redundancy, but generally speaking, the iterator should have the increment operations. It should be movable. It also should be dereferenceable. The input iterator concept doesn't require comparison between two iterators for input iterator. The legacy input iterator named requirement requires this, but the concept does not. And this is quite convenient because actually we do not know when, so it's hard to compare the two input operators. Yeah? So the idea is that the one that is supposed to be used as some form of sentinel to find the end of this operation. Yeah, so it somehow should have some properties that are distinguishable for the end of the operation. Yeah, but generally now it's not needed, and we can use this and to implement our input iterator that will work with our database. So let's go through that, or let's go through an example. Yeah, so generally we need to provide some aliases that are required by the concept. First of all, we need to provide the iterator category. In our case, this is input iterator tag. We also need to provide difference type and value type. So the reference in our case will be constant reference because we provide read-only access. So then what we need to have is, generally we will have some function that will be performing the navigation of the cursor, but when we create the cursor, we probably position the cursor at the beginning, and then we can also, so the iterator either kind of has access to the cursor or it owns the cursor, but generally we here use expected, so this is the item that we either can read the item and store it in our expected, or there will be an error, including the error that we reach the end because of some condition. And this is what we use, so we kind of modify this item within our operations, and navigate cursor is the base of the implementation of our cursor. And it looks like that, yeah? So we actually have the operation parameter, and we just forward this to the MDB cursor get, and we go to the first or to the next, depending in what operation we are calling in for our iterator, and then we just kind of either we read the data and assign it as an expected type, or we assign an error. Yeah, so something like this. Then our just increment operators will just delegate this to our navigate cursor. And what we need to have comparison operator with the default sentinel. This is now also C++20 facility. This is just a type that can be used to actually represent the end of iteration condition. Yeah, so something that with which we need to compare and say that we are equal if we cannot read the data anymore in our iterator. Yeah, so something like this we implement this, and this is the end condition for the iteration. And generally in our case, if some error happened, we stop the iteration. We also have a helper error. Why? Because iterators and in general, so it would be easier if we could throw exceptions here. Why? Because we are kind of iterating. If some error happens, we throw an exception and we immediately report the problem. We need to find workarounds how we can handle this if we do not use the exceptions. In some case, we can just stop iterating and then we can check the iterator was. But it's not ideal, honestly. So another approach is that to use some callbacks, but callbacks they are so in embedded it's quite often used, but typically this is those handlers already lead to some unrecoverable state of the whole system. Yeah. So the thing is that exceptions are quite to some extent are really, yeah, they are needed in this case actually. So, and to have this whole iteration, yeah, it's a good indicator. Yes, sorry, somehow, yeah. Sorry, 3 minutes more, sorry. So we are, so we have, yeah, so, and our objects, yeah, they can provide different types of iteration. Yeah, so there is an iteration like iteration through the whole database, there is iteration by key. That means that generally they should return some kind of the range. And the range object this range that is based on the iterators that we developed. We developed the very base one that just iterates through the whole database. There can be more specific ones where we provide the key, for example, but generally the range is something range is something that generally can be used in this ranges begin and ranges end operator. There can be passed as parameters here. And the idea we need to have this range that will be returned by these functions. And in our case, so we will be used a kind of lightweight proxy that we can make to be a view. Yeah, so generally, and the view, there is also concepts for the view. It is also much better documented now. And our view that will be using the iterator will look like this. Yeah, so we will have just begin and end functions that will return our iterator or default sentinel. So when we return this view, and the cursor will be owned by view and will be passed as a reference to our iterator. The thing is that here is, by the way, the exceptions are probably even more required. So this is really challenging to really handle this without the exceptions if there are some errors within iterator, because if we use the ranges operator and if we kind of create the view and pass it right into the function. So this really can be challenging and limiting to some extent. Yes, so this is how we are doing this. Okay, and to access the items, the iterator, it returns just the type that is called RAII item that provides lazy access to the values within the database. Yeah, so we have here the deserialization traits, and on demand, it converts the spans that it owns that references the data within the database. So deserializes into values. Okay, and so for this RAII item, we can actually implement structured bindings. Yes, so structured bindings is facilities that can be implemented with custom types. So generally speaking, we need to have specialization of some of the standard facilities here. So we need to provide tuple size, tuple element, and then also ADL visible get function. Yes, so this is also something that can be done and bring some convenience actually that for some types that where the access to some items can be actually binded. Okay, yeah. So last remark. So runtime efficiency. Yeah, so in our implementation, we did not use any virtual methods. We also did not have any memory allocation within our repo. And we also, of course, our compile time logic, it does not affect the runtime. Yeah, so this is just a kind of receipt. So the object dump produces this if we have the GCC 1203. So our kind of populating of the database created basically is mostly inline. Yes, so we do not have any indirect calls. So generally there is nowhere where we can get them in our implementation. Yes, so generally we just operate with the calls to our APIs. So the last thing that unfortunately, yes, definitely does not fit into this slot. So we have the testability issue. The repo code is supposed to be tested. Why? Because we definitely do not want to introduce the errors we want user to protect from by our repo. Yeah? So we don't want to have them inside our implementation. This is a complex problem, but it was, I tried to cover it in another talk that is called Test-Driven Development of Embedded and System-Level Software that was present in April this year. So if you are interested in this, please let's talk about this now, but we need actually, unfortunately, just to finish this particular presentation, and let's talk about this and chat about this after the session. Okay, yeah, then I'm switching to this slide, and I really appreciate your attention, and sorry for the delay with that. Thank you very much.